Mechanics. Mechanics is a branch of physics that deals with the behavior of objects and the forces acting upon them. It's essentially the study of motion, forces, and energy. Mechanics has a vast range of applications from everyday phenomena like driving a car to the complex movements of celestial bodies in space. Understanding mechanics is fundamental to both classical and modern physics, making it one of the fundamental pillars of science. Types of mechanics. Mechanics can be broadly classified into two main types: classical mechanics and quantum mechanics. Classical mechanics. Classical mechanics deals with macroscopic objects and describe how they move and interact with forces. It is divided into two main categories: kinematics and dynamics. Kinematics, the study of motion without considering the cause of motion. It focuses on parameters such as velocity, acceleration, displacement, and time. For example, kinematics can explain how a car accelerates from one point to another, but not why. Dynamics, the study of the forces and torques that causes motion. This includes Newton's third law of motion, which are essential to understanding how objects interact. For instance, when you push a book across a table, the forces you apply and the friction opposing it are both considered in dynamics. Newton's law of motion adds center to classical mechanics. First law, inertia. An object will remain at rest or move in a straight line unless acted upon by an external force. Second law, force equal to mass into acceleration. The force acting on an object is equal to its mass multiplied by its acceleration. Third law, action reaction. For every action there is an equal and opposite reaction. Classical mechanics also include energy principles such as work energy and the conservation of energy, which help explain how energy is transferred between objects. Quantum mechanics. Quantum mechanics, on the other hand, deals with the motion and interaction of particles at the atomic and subatomic levels. It is essential for understanding the behavior of electrons, protons, and other fundamental particles, unlike classical mechanics, where objects have well-defined positions and velocities. Quantum mechanics introduce probabilities and uncertainties through principles like wave-particle duality and Heisenberg's uncertainty principle. While classical mechanics is applicable in everyday life, quantum mechanics becomes insignificant when examining the world at a microscopic scale. Applications of mechanics. Mechanics plays a critical role in various fields such as engineering, astronomy, sports and biomechanics, and automotive industries. In engineering, from designing bridges to constructing airplanes, mechanics is essential in ensuring that structure and machine operate safely and efficiently. Astronomy. Understanding planetary motion, gravitational forces, and orbital dynamics allows us to explore space-launched satellites and predict celestial events. Sports and biomechanics. Mechanics is used to improve athletic performance by analyzing how force interact with the human body. Automotive industry. Car manufacturers rely on mechanics to improve vehicle safety, optimize fuel efficiency, and enhance performance. Conclusion. Mechanics is the bedrock of physical science, but it is the movement of a vehicle, the orbit of the planets, or the behavior of tiny particles. Mechanics provides the tools to understand and predict how forces influence motion. By mastering the principle of mechanics, we can apply them across countless industries and unlock a deeper understanding of the universe.